My name is Ivan, and to keep it simple, together with the other Ivan, today we'll share our journey at the World Bank of how we decided to build that infrastructure to meet the needs that we had. As a reminder, there will be a session survey. Please complete that after the session. Thank you for that. So at the World Bank, our mission is to end poverty and boost shared prosperity. We do projects that we do hundreds of projects in hundreds of countries every single year. And to do that, we really need data. So data-driven decision making is at the core of almost everything that we do. For the past 60 years at the World Bank, we've collected vast amount of data, being that structured, unstructured, semi-structured. There are over, I always keep on forgetting these numbers. There are over 1,000 applications that currently work and need to use this data in all kinds of forms and fashions. Again, we have over 300 terabytes of data that we process daily. Our overall data storage is probably somewhere around like the upwards of 30 petabytes. And this is not everything. This is just the data that I have kind of been able to see and work with. When we started our cloud journey several years ago, we said, okay, so there's that much data. We need to figure out how this data is accessible. How do we eliminate these data silos? And when everyone started kind of moving to the cloud, these silos just kept on growing and growing. So I said, okay, what are we missing? A couple of years ago, we decided, okay, so let's do our forward-looking strategy and focus on 6 things. Let's remove these data silos, but at the same time, keep an open and democratized framework. Let the applications and application teams and whomever needs to work with data work in the platform and the system that they want to do that in, but also enable them to be to bring their data in a centralized platform where you have out-of-the-box capabilities such as data protection, such as integration, such as making this data out of the box available to everyone in that organization. We couldn't really forget about scale and performance, so that was a core. And when we started looking at what was available on the market, we kind of naturally decided to choose Databricks. Not only because it was really easy to get on board with the platform, but because back at the days it was secure, it was integrated. It is quite agile, and the time to market with whatever you start doing on Databricks is extremely fast compared to everything else that we've been doing. So we said, okay, we place Databricks at the center, and if we need to bring some data in, we bring it in, we expose it through Unity Catalog, but how do we make this data available to everyone else? What is this other thing that we need to make also available in that platform so that the integration is seamless and everything is protected? Before we get there, so we identified generally 3 large use cases of what we needed to solve. So if you're on our serving layer, your downstream applications could have been any data products that you might be running, any data catalogs that you might be running locally, or any visualization and enterprise reporting. So by the way, fun fact, if you Google today corporate scorecard, Data 360, or Finances One, these are all platforms that are available as public good. You can download data out of them, and it's all powered by Databricks. The second very important scenario was self-service. I mean, everyone wants self-service. Everyone want to do their reporting or data preparation themselves. They don't want to depend on a central team. So this is a second big scenario that we needed to support. And of course, well, in our case, just to mention, but Ivan will be sharing more in a bit, we're talking about Power BI, we're talking about Databricks, we're talking about Tableau in these scenarios. And of course, we have transactional applications Some of them needed to consume data out of Databricks. How do we make this available? Databricks is it's a big data processing engine. So can we really scale it to meet application demands? And of course, everything needs to be protected, governed, and made secure, just available out of the box. Most of the times, if you work on a platform, you have to do all these additional governance and privacy things additionally, and it's often overlooked. So we decided, okay, let's bring it as part of the offering, and let's just allow people to use it out of the box. Slightly more on the technical requirements. So, okay, so because these three large scenarios were quite, I would say, complex and complicated, but we decided to follow best practices and chose the most critical, the most sensitive, and most protected use case to get started with. So we had to focus on three major, I would say, deliverables. So these scenarios in the AI BI world, this pretty much meant we needed to deal with hundreds of users simultaneously, getting reports in Power BI, using direct query to Databricks over a fact table which had more than 1 billion records. At the same time, render time needs to be less than 10 to 15 seconds, sometimes even less. When it comes to applications, we wanted, so we had applications and all of them pretty much consume data over JDBC, ODBC, or REST APIs. So we had to make sure that this is available, supported, and performant. We wanted to allow external engines to be able to bring their data in, oracles, SQL servers, whatnot. And last but not least, enterprise integration. The one thing that is, again, often overlooked when people choose platforms and solutions. Enter integration was a key because Active Directory, permission management, unless you streamline it, then you set up yourself for failure. Row level security, object level security, masking, everything needed to be out of the box. And of course, integration with other enterprise platforms running on the back end, such as Splunk, had to be available out of the box. How did we achieve all this? So I'll pass the baton to Ivan to share more on the lessons that we learned and how we solved some of the challenges that we had.
Thanks, Ivan. I hope everyone can hear me. Okay, so we covered our technical requirements and our forward-looking strategy. So now let me tell you how we did this in action. So here on the screen, you can see the building platform, the building blocks of our platform. At the bottom, we have our open data lake, where we are storing all the raw data and all various data sources. Then, on top of it, we have the Delta Lake uniform layer. We make sure that all the data that sits in the lakehouse is using Delta Lake format, because this ensures we have ACID transactions, we have time travel capabilities, and also we can enable the uniform format, which can then be accessed by other engines like Hoodie or Iceberg. Then at the center of our solution, we have Unity Catalog, which is our centralized governance for the lakehouse. And of course, it helps us with the discovery, with the access control, lineage, and of course, auditing and monitoring. The next layer is, I would say, these are the three different serving tiers. The first one is the quasi-compute. This is the tier which is sitting inside our cloud premises, or by our cloud premises, I mean our Azure tenant. Under this category, we have the interactive cluster and the regular SQL warehouse. The next one is the serverless compute tier, which is pretty much all the compute which is provided by Databricks. Here we have the serverless SQL warehouse, Here we have the serverless compute for notebooks, the model serving, etc. And then last but not least, we have the API services tier, which we are using for either data share or for our custom integration with Azure API management. Of course, on the top, the most important layer, I would say, this is the network and workspace isolation layer. We shouldn't compromise on compliance, so we make sure that everything is well isolated and we are following all best security practices. For example, all our workspaces are isolated. We have IP access controls, we have egress controls, we have private endpoints, and all the goodies that Databricks provide us. With that said, what we did is we found 6 different serving scenarios, and each of these serving scenario we pretty much aligned to specific user persona or application type, and we are using these 6 engines that you can see on the screen for serving them out of Databricks. The engines are SQL Warehouse, API management, data share, federation, OLTP, and model serving. And what we are going to do now is we will go over each of these serving scenario in more details, and we will talk about some best practices, some trade-offs that we had to do, and what we learned down the road. And by the end of this presentation, our idea is for you to have like a blueprint which you can use for to implement those scenarios in your organization or your Databricks environment. Okay, so let's start with the first one, and this is the AI and BI applications. Under this pattern, we have the BI tools, the Microsoft Fabric integration, and the Databricks Genie integration. If we start with the BI tools, here the first thing is we need to use the SQL Warehouse. That's needed because the SQL Warehouse is highly optimized for the SQL for any SQL workloads, so it's best to use it. Then we need to make one decision whether we want to use serverless or classic compute. If we select if we choose to use the classic compute, we have some benefits like we can do better on the network isolation part, and also it's cheaper than the serverless option. But there are also some downsides, like the starting time is around 5 minutes. So if you're running direct query reports, this means that you probably need to run your cluster 24/7, which could be really costly at the end of the day. From the other side, we have this serverless option, which is costlier, but the starting time is much faster, and also it has all the latest and greatest features by Databricks out of the box. So based on our requirements, we need to choose which one is better for us. The next one and the next decision we need to make is if we want to scale out or if we want to scale up. Sometimes it's needed to scale both, but this is another thing. The rule of the thumb here would be if you're running very big workloads, like you're processing a lot of data, big tables, and you have big workloads, we go with the scale up. And then how we can see if we need to scale up our cluster. We can do this, for example, by going to the query history and run through our queries, and then there we can see if there is any data that's being spilled on the disk. If there is such data, we can scale up. From other side, if we are running direct query reports and if we are expecting hundreds of users hitting constantly the warehouse, then we need to go with the scale out option, just because each cluster in Databricks can handle up to 10 parallel queries only. The next one is the SQL driver limitation currently, and this is specifically for Power BI. The Power BI driver is producing some non-ANSI SQL queries, and it's nesting queries, which is really strange, and Databricks is not very good at optimizing this. So if you are creating a reports, direct query reports, you might see some strange queries that are being produced in Databricks. So I know that Databricks is currently working on fixing that. So we hope the next couple of months this has been fixed. And then the caching and the cache warm-up, really important topic. It's really essential for you to use the caching functionality because it speeds the processing a lot. But here there is one thing that you need to know. The caching is per user. So if you're running a direct query report and you don't have the necessity for row level security or column level masking, then probably it's a better idea to use a common service account, which is throwing all the queries so your queries can be cached at the end of the day. And the next one is the cache warm-up. It's a good idea to preheat your cluster. So when the users are opening the reports, they are performing good, and the first user do not see the first caching queries. But you need to know something here as well. It appears that if you're using a scale out cluster, the cache is not being replicated through the nodes. So if you have, for example, a cluster with 2 nodes and the data is being cached on the first one, if the cluster scales out to a second cluster, to a second node, and then a user comes in, this means that the second user won't hit the cache and it will have not so good performance as the first one. The next integration we have in place is Microsoft Fabric integration. Here pretty much we have 3 options. The first is we can orchestrate with Data Factory and move the data from Databricks to Fabric. The thing here is you need to make a data copy, which is something that you need to decide if you're okay with. The second option is we can use Fabric shortcuts or Databricks mirroring functionality, but these are features in public preview, and also something really important, they do not support the Fabric mirror, the Databricks mirroring does not support workspaces that are behind the private firewall, behind the firewall. So this means that if you want to build an enterprise grade solution, you can't use this option. And the third option is Databricks writing to one lake. The idea here is you can move your GOAT layer from Databricks to Microsoft Fabric, but I don't know if I can recommend you that. The last option here for integration is Databricks Genie, which is also utilizing SQL Warehouse. And the best practice here would be to create a separate SQL Warehouse for all your Genie workloads. This will ensure they have enough bandwidth, they are not being throttled by other workloads, and also it's easier for you to monitor the cost that's being produced by the Genie space. Okay, so we spent a lot of time here on this slide, but we put a lot of work together with our data engineering team and the team from Databricks and Microsoft. So we thought it's a good idea to share all these insights with you guys. Going to the next integration, here we have the application integration, which we are splitting into 2 categories. The first one is the high latency applications, which are basically all the applications that do not require millisecond performance, and they are using typically JDBC, ODBC, or REST API. Here, the main challenge was to see if we can if Databricks can meet our serving requirements. So in order to do that, what we did was we decided to use Apache JMeter together with Azure load testing, and to pretty much see how much, where are the limits of our SQL warehouses. So we tested different scenarios, like we run 200 queries per second, we run 500 users simultaneously, etc. So at the end of the day, we wanted to see how well it scales, and as I said, where are the limits. So also one other thing to ensure that we have a realistic tests, we did the following. We created a script which is pretty much shuffling different SQL queries and also shuffling different where statements. So we ensure that we don't hit the cache and the results are realistic as possible. So the outcome was, first, the SQL warehouse was meeting our core requirements for data serving. The second one was something that we found for JMeter, and the problem with JMeter is it doesn't support Apache Arrow. So the results from the tests are slower than the actual one. So we decided there to, in order to meet our requirements, we need to meet the test without Apache Arrow. This would mean that we would have some gap for errors. And the last one was for the large data set and the driver performance. It turns out that all the results that are being produced, if they are more than 1 megabyte, they are being processed directly in Databricks memory, and they are super fast. But if the results are more than 1 megabyte, then Databricks creates like a chunk files and stores them in the DBFS. And then the driver downloads those results from the DBFS. The API management, we decided instead of using Databricks native REST API, we created a wrapper on top which uses Azure API management. This ensures additional security, and it's easier for the users to hit the REST API. They can just provide the warehouse ID and they're ready to go. The second option and the second category is our low latency applications. And these are the applications which are our most critical ones, and they require millisecond performance. Here, currently we are creating a copy inside a SQL server, and we are having a Redis cache layer on top. And this ensures super fast performance, plus data is always there, it's available, and it's ready to use. The downside here is we are creating additional data copy, but you need to make a trade-off in order to meet your requirements sometimes. And the other option that we are currently exploring, and I don't know how much we can talk about it, is Databricks OLTP. Pretty much this should be a Postgre instance inside Databricks, and the idea is to move the SQL and Redis cache pattern inside Databricks, so we can use all the goodies from Unity catalog, the common governance, the common access control, etc. The next pattern would be AI and ML serving, where we are currently exploring, but we find out a few things that were worth mentioning. The first one is paper token versus provision and throughput. If you're doing developments or you're testing something, it's better to use the paper token option because it's cheaper and it's like you're paying only for what you're using basically. But once your model is production ready and you want to move it to production, then it's better to go to provision throughput. This will ensure you have reserved bandwidth and reserved query per seconds. And also one important option with the provision throughput is to make sure you click on scale to 0 option. This pretty much shuts down the endpoint 30 minutes after no one is like using it. So it saves a lot of costs. Also, we are exploring the Mosaic AI Gateway, the AI agent framework, and the feature serving. And we are trying to understand how they can help us with like checking what's going on, what's the usage, who is using the endpoints, how we can create a better chatbots and LLMs together with the API. But the work here is currently in progress. So I will skip to the next part because we are running out of time. The next layer is data virtualization. And here, basically the goal is we wanted to bring our existing data sources inside Databricks. So not all of our data sources can be easily moved to Databricks. So we had to have a way to serve it from there. So because at the end of the day, we wanted this one unified serving layer that is available and it's managed only from one place instead of having like segregated systems. So to achieve this, we decided to use Databricks federation capabilities. And here we found out 3 important considerations that I want to share with you today. The first one is the limited available engines. So currently, there are not enough supported data sources, so you cannot connect your entire data like landscape. The good thing though is Databricks is currently working on that, and they are constantly pushing new connectors. And today I was at one session where the presenters show us the roadmap, and it seems like this issue will be fixed soon. The second one is the performance overhead, and what I mean by that is pretty much your data lives in the source, and in order to serve it out of Databricks, it needs to create one additional data hub through Databricks. So if you are running a workload that require very fast performance, probably that's not the best idea for you, and it's better to move your workloads to Databricks. Or as an alternative, you can create a materialized view on top of this federated table, which can sync the data and can ensure you have capacity to run. And the last one is the cost. Just because the queries are being run both on Databricks and on the database engine, it's generating cost on both ends. So it's good practice to monitor your system tables and to monitor what's the cost that's being generated. Also, this promotes and supports the data mesh architecture where different teams can work on their preferred engines, and they can expose the data through one and only serving layer, which is Unity Catalog. And also, it can enhance the analytics with data without copying, just because you are not storing anything in Databricks and you are hitting directly the source and the endpoint. The next one is the internal data sharing, and here our main idea is to have pretty much to leverage as much as possible the data share capabilities. And to be more specific, we want to we are currently evaluating how we can use the private exchange. That's because we can use the private exchange to pretty much share data securely across the organization, and also other people and other teams can discover this data from one single place. And we are trying to see if we can implement this in our current data cataloging system, so we have everything on one place. Of course, this again supports the data product mindset, because you can publish the entire data product within the private exchange, and other people can like see the notebooks, the flows, the lineage, the data itself, and everything could be stored in one place. And also it eliminates the data silos, and you don't do any copy across regions or organizations. The last one is the external sharing. And here, pretty much we want to enable the users to share data across organization in secured manner, and this to be backed up by Unity catalog governance and access control. We want to also exploring how we can utilize it to publish public data products and make them available for the wide audience. But this one is currently in progress, so that's why I don't have much to share. So pretty much that was what I wanted to cover. So now I will pass again to Ivan.
Okay, thanks. So like it's not really an easy thing to make a centralized data layer. But what we figured is that we need to make sure we cover, I don't know, 80–90% of the scenarios and do tailored solutioning for everything else. If you have your critical applications, sensitive applications, probably you don't want to run them out of a common serving scenario, such as this one. But what you get is, if you have your data available and discoverable and accessible in a centralized, protected platform that is enabled for AI, ML, and all of these futuristic and forward-looking applications that we want to build, then probably you can sacrifice here and there a performance on an integration scenario. Usually design should follow your requirements. So again, there's no solution, one solution to fit them all. So you have to be opportunistic. And of course, most importantly, be careful with vendor-specific drivers. Sometimes there are some hidden things that you understand only after you go in production and start hitting performance challenges. The Power BI thing, the Apache Arrow thing, so all those things that Ivan shared. And with that, I think we have 6 more minutes. This is all that we had to share. And we will open now the floor for questions. If you have a question, please speak up on the mic.